Hi everyone! Today we're going to continue talking about systems of linear equations, and specifically we're going to talk about systems of inequalities. Our objective for today is that students will be able to solve systems of linear inequalities by graphing. Let's get started. When we're talking about systems of linear inequalities, remember an inequality is an equation, but instead of an equal sign we have less than, greater than, less than or equal to, or greater than or equal to. All right, so when we're dealing with systems of linear inequalities, the solution to a system of linear inequalities is the set of ordered pairs that satisfies all the linear inequalities. So what that means is the solution to inequalities, it's all of the ordered pairs, so all of the points that fall in between the parts that are overlapping when we shade. Okay, because that's the parts that are overlapping when we shade, because remember we always shade when we're dealing with linear inequalities. The parts that overlap when we're shading would be the part that satisfies all the linear inequalities. And we can show the solution by graphing. So the first thing we want to do when we're solving systems of linear equalities is graph and shade each linear inequality. Okay, so you want to shade them both separately. And the solution to the system is where the shading overlaps. All right, let's go through a couple examples of this. All right, so example number 1, we want to graph each system of linear inequalities and clearly indicate the solution region. All right, so first we want to start out by graphing the first linear inequality. So it's already in slope-intercept form, so we can identify our y-intercept is -1, so we put a dot on the y-axis at -1. And our slope is -2/3. So that means we're going to go down 2 and to the right 3. Down 2 and to the right 3. And if we want it in the other direction, we're going to go up 2 and to the left 3. Up 2 and to the left 3. All right, and there are all of our points for that first inequality. Now, because it's less than or equal to, that means we do a solid line. If it was just less than, it would be a dashed line. All right, but because it's less than or equal to, we want a solid line going through all the points. All right, and you're using a ruler, so it goes through all of the points. All right, let me fix my line. There we go. We want to put arrows on both ends, so it shows that it goes on forever in both directions. And then because it's less than, all right, less than or equal to, that means we want to shade below. All right, so what I'm going to do is shade below the line. So that is the solution to the first linear inequality. Then we want to do the second one. Okay, so we want to shade the second linear inequality. And we know that our y-intercept is -8, so we're going to go down 8 on our graph, on our y-axis, and that would be right there. Okay, then our slope is 1/2, so we're going to go up 1 over 2. Up 1 over 2, and we're going to keep going. All right, now because it's greater than or equal to, that means solid line, so we connect our dots. And we use a ruler, so it's a nice straight line going through all of the points. Put arrows on both ends, showing it goes on forever in both directions. And then because it's greater than or equal to, we want to shade above. All right, so we're going to shade above the yellow line. So we would go up this way, and that would be shading above. Now, the solution to our system of linear inequalities is the area where they overlap. So if you're only using a single colored pencil, right, just a standard gray lead pencil, all right, what I would want you to do is shade the part where they overlap extra dark, all right? But I highly recommend, if you want to make it extremely clear to me what is your solution, use a highlighter or a marker or a different colored pen to show me where is the part they're overlapping. All right, so what I'm going to do is use a different color, and I'm going to highlight where they are overlapping, and that is this part right here. All right, so that would be the solution to our linear inequality. All right, if you want to put a big S in there to show me that is the solution, that would be great as well. That's one other way to indicate that is the solution to our system of linear inequalities. And we're done. All right, so number 3, we've got two linear inequalities, but before we can graph them, we need to change them to slope-intercept form, all right? We can't graph them in standard form. We don't know where the y-intercept is or what the slope is. So we want to take each linear inequality and convert it to slope-intercept form so it's easy to graph. So starting with this first one, we've got x minus y is greater than 1. We want to subtract x from both sides. Cancels out over here. We're left with negative y is greater than negative x plus 1. Now, y is not by itself yet. There's still a negative 1 next to it. All right, it's a negative y, so we have to divide both sides by negative 1. So we get y. And remember, if we're multiplying or dividing both sides of an inequality by a negative number, we have to switch the sign. So we get y is less than positive x minus 1. And there is our first linear inequality. Now our second one, we want to change this to slope-intercept form. All right, so we've got x plus 4y is greater than 20. We want to subtract x from both sides. We've got 4y is greater than negative x plus 20. Divide both sides by 4. All right, we're dividing by a positive number, so we do not have to switch the sign. We end up with negative 1/4 x plus 5. All right, so there's our two linear inequalities that we are going to graph. And now that they're both in slope-intercept form, it's much easier to graph. So our first one, let's go with our green one first, our first linear inequality. So our y-intercept is negative 1, and our slope is positive 1. So we know we're going to go up 1 to the right 1, up 1 to the right 1, and we're going to keep going up. All right, and then we want to get an idea of what it looks like in the other direction as well. So we would go down 1 to the left 1, down 1 to the left 1. All right, and there's all of our points. Now, because this is just less than, y is less than x minus 1, it's going to be a dashed or dotted line. All right, it is not a solid line, it is a dashed line. So when we're connecting our points, we want to be sure to use a dashed line here. Okay. And then for this one, we're going to shade below the line because it's less than. So we shade below the line. Now our second linear inequality, y is greater than negative 1/4 x plus 5. Start with our y-intercept. We go y-axis up 5, put a point. Then our slope is negative 1/4, so we're going to go down 1 and to the right 4. Down 1 and to the right 4. All right. Then if we want to go in the other direction, we would go up 1 and to the left 4, up 1 and to the left 4. There's what all of our points look like for our yellow one. Connect all of our dots, and we're using a dashed line again because it's just greater than. All right, dashed line there. And for this one, we want to shade above. Okay, so we shade above this line, so that would be this part up here. Now, the only parts where they overlap would be this little section right here. All right, so that is our solution to this system of linear inequalities. All right, so I want you guys to try number 5 on your own. All right, so remember first, convert them to slope-intercept form so they're easy to graph. Shade them both separately, and the part where they overlap is your solution. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now and give this one a try. All right, so your graph should look something like this, where this area right here is your solution. You should have converted the first linear inequality to y is less than negative 1/2 x minus 3. And you should have converted the second inequality to y is greater than negative 2x plus 5. So the key with this one is to remember to switch the sign because you have to divide by a negative number. All right, so make sure you had switched the sign with that second one. All right, and we graph the green one, so we go negative 3, slope is negative 1/2, so down 1 to the right 2, down 1 to the right 2, and then to go in the other direction, we would go up 1 to the left 2, up 1 to the left 2, and we shade below that one. All right, for the second one, we go to positive 5 as our y-intercept, Slope is -2, so we would go down 2 to the right 1, down 2 to the right 1. We would do a dashed line again, straight above, which would be this section, and the part where they overlap is right there. All right, if you have any questions on this, call me over so I can help you. Otherwise, let's move on. All right, number 7. If you were to see a problem like this where it's asking which points are solutions to the system of inequalities below, and we want to check all that apply, what you would do is you would need to test out each and every point. So how do we do this? How do we test out points? So what we would do is we would say 1, 1, all right? 1 is our x, 1 is our y, and we would take them and plug them back into both equations. So with our first one, we would say x minus 6y is greater than -48. Well, we know x is 1, minus 6 times y is also 1. Is that greater than -48? And then we just simplify. So 1 minus 6, and then we ask ourselves, is -5 greater than -48? Yes, it is. All right, so this point works in that first inequality. Then what we want to do is test it out in the second one. So we would say 2 times x, and we know x is 1 for this point, plus 3y, y is 1. Is that less than 9? So 2 plus 3, and is 5 less than 9? Is this a true mathematical statement? The answer is yes. So we plugged 1, 1 into both equations, and we got 2 true mathematical statements. All right, so yes, 1, 1 is a solution to the system of inequalities. So we check it off. Then we want to continue checking all of the points. All right, so I'm going to need more space here, so I'm going to make things small. And now we want to test -2, 6. All right, so let's see if -2, 6 gives us true mathematical statements when we plug them back into both inequalities. So if x is -2, we're going to say -2 minus 6 times y, and y would be 6. Is that greater than -48? So -2 minus 36 is -38 greater than -48? And the answer is yes. Yes, it is. All right, now we want to test it in the other inequality. So we ask ourselves 2 times x, and x would be -2, plus 3 times y. Y is 6. Is that less than 9? So -4 plus 18 is 14 less than 9? The answer to that is no. All right? This is not a true mathematical statement. So therefore, because it does not work in the second inequality, -2, 6 is not a solution to this system of inequalities. All right? Now I want you guys to continue checking all of these points. So check the last 4. Pause your video and check those last 4. When you come back, I'll have the answers written on your screen and we'll go through it together. All right, so go ahead and pause your video now and check those last 4 points. All right, so I know this problem involved a lot of work, and I'm sorry if it's a little hard to read on here. All right, but I had to zoom out and zoom back in a couple times in order to fit it all in here. Okay, so you should have gotten that your 3 solutions, your 3 points that are solutions to the system of inequalities are 1, 1, -8, -3, and 4, -7. All right, we tested these 2 points together, and then you should have tested 9, -2, and you figure out the first one, it works in the first inequality, but not the second one. All right, so we don't include 9, -2. Then when you get to -8, -3, it works in both of them. All right, we get 2 true mathematical statements when we plug them in. So -8, -3 works. Then when you tested 3, 4, it works in the first inequality, but not the second. 18 is not less than 9. So we do not include 3, 4 as a solution. Then last but not least, we test 4, -7, and we get 2 true mathematical statements. So we include 4, -7 as a solution. All right? If you have any questions on this, call me over so I can help you. If you need to pause your video and check your work with what I have written here, go ahead and do that. Otherwise, let's move on. All right, so the last example we're going to do together is, of course, a word problem. So number 9. Greg needs at least $1.60 in stamps to mail a package. He has 28-cent stamps and 4-cent stamps. He can use no more than 24-cent stamps as he only has one book left. All right, so our goal is to write a system of linear inequalities that represents the situation and then graph it. And the first thing we want to do before we write our systems of linear inequalities is we want to define our variables. So let's say that x equals 28-cent stamps, okay? And we're going to say that y equals the 4-cent stamps, okay? So we define our variables. What is x and what is y? Now we know that he needs at least $1.60 in stamps to mail a package. All right, and what we would want to do is we would want to write an inequality that represents this value. So we know that each 28-cent stamp is worth 28 cents. So we would say 0.28 times x times the number of 28-cent stamps, plus we know a 4-cent stamp is 0.04 times the number of 4-cent stamps, has to be at least, so greater than or equal to $1.60. Okay, that is our first inequality that we need. All right, that's one that represents the value. So going back to what we talked about last lesson when we're dealing with applications of systems, one's going to represent the value and one's going to represent the quantity. All right, and the only information we have about the quantity is that he can use no more than 24-cent stamps. So 4-cent stamps are y, so we know that y has to be less than or equal to 20 because he only has 24-cent stamps, so he can't use more than 24-cent stamps. So there is our 2 linear inequalities that we are going to use. All right, now we want to graph these. Now before we can graph this one, we need to convert it to slope-intercept form. All right, because we can't graph it if it's in standard form like this. So I'm going to zoom out a little bit and give us the opportunity to go up here. Hopefully you have more space on your paper, and we're going to convert this. So the first thing we would do is subtract 28.28x from both sides. So we would end up with 0.04y is greater than or equal to negative 0.28y, not y, x. What am I doing? All right, x plus $1.60. Okay, so what we did is we subtracted 0.28x from both sides. Now we want to divide both sides by 0.04. Divide both sides by 0.04. They'll cancel out over here. We're dividing by a positive number, so we do not have to switch the sign. So we end up with y is greater than or equal to negative 0.28 divided by 0.4 is going to give us negative 7. So negative 7x plus $1.60 divided by 4 cents gives us, that gives us 40. Okay, so there's our new linear inequality, and now it's in slope-intercept form, so it's much easier to graph. All right, so I'm just going to write it down here, so when we zoom back in, we can still see it. So y is greater than or equal to negative 7x plus 40. All right, that is our equation in slope-intercept form. Now I'm going to zoom back in. All right, so there is our first inequality we want to graph. And then our second one would just be y is less than or equal to 20. All right, so we want to graph this on our graph right here. Now it's a little zoomed out, so that's okay, but we still want to be sure to label our axes. Okay, so we know that x is going to represent the 28-cent stamps. All right, so we label 28-cent stamps down here, and y is going to represent the 4-cent stamps. Okay, so we label the 4-cent stamps up there. Now we want these to be in equal intervals. Now we're going to be going up to 40 on our y-axis, so we probably want to go by at least 5s. So let's say 5, and that's going to be 10, 15, 20, 25, 30, 35, 40, 45, 50, all right? And on your paper, hopefully it's easier to graph this. Then 60, then 70 up here, okay? And we want to do the same equal intervals on our x-axis. So this would be 10, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. All right, so we know what our intervals are going to be like here. Okay, now we want to graph our first inequality, which is y is greater than or equal to negative 7x plus 40. So we know our y-intercept is going to be at 40, so we go up to 40 and put a dot. Now, if we wanted to plot our next point, what we would do is plug 10 in for x. So if we plugged 10 in for x here, right, we would get 10 times negative 7, which would give us negative 70, plus 40, okay? And then plus 40 would give us negative 30. That would be way off our graph. So let's not do that. Let's plug in 5. If we plugged 5 in, we would get negative 30, negative 35, plus 40, which would give us 5. So we know when x is 5, y is 5 as well. And there's our second point. All right, so that is how we would graph this in linear inequality. And we want our line, so we draw, I picked the wrong line, sorry guys. We want a line, and it's a solid line, so we would go that way because it's greater than or equal to, and we know it's going forever in both directions. And then we want to shade above because it's greater than, okay? So we would shade above this line, which would be this side over here, okay? So this would be shading above the line. Now we want to graph our second one, all right? Our second one was y is less than or equal to 20. So y equals a number is always a horizontal line. So we know we're going to have a horizontal line at 20, okay? So we put a dot at 20, which would be right there, and we want a horizontal line at that point because y equals a number is always horizontal, and because it's less than or equal to, it's going to be solid. So we would do a horizontal line, okay, and let's see, there we go, and we know it's going on forever to the right, so we put an arrow, and then we want to shade below this line because it's less than or equal to 20. So we shade below this line, and that would be down here. All right, so our solution to this system of linear inequalities would be this area right here. Where do they overlap? All right, this would be our solution. And remember, we can put an S in there to remind us that that is our solution. All right, so we just graphed this system of linear inequalities to represent this situation. Now, using our graph, we want to give two possible combinations of stamps that Greg can use to ensure he mails his package with the correct postage. So what you would want to do is just pick 2 points that fall in this solution area. So let's say, for example, let's say 20, 10. That would be a solution. So if x is 20, y is 10. That is a solution to this, okay? Another solution would be 70, 10. All right? 70, 10. Those are both solutions. So what he could do is he could use 2010 represents 20 28-cent stamps and 10 4-cent stamps. All right, because we know x represents 28-cent stamps and y represents 4-cent stamps. All right, and then 70-10 would represent 70 28-cent stamps and 10 4-cent stamps. And these would both be solutions to this situation. All right, so we could pick any 2 points that fall in that interval, and that would be our solution. All right, so if you have any questions about this problem or just anything in general about systems of linear inequalities, call me over so I can help you. Otherwise, I hope you learned a thing or two about these today, about systems of linear inequalities. Look to the board to see what to do next, and I hope that you have a great day. Bye.